Here's an example, once again, of showing events that are not mutually exclusive. There are 10 balls that are numbered 1 to 10. What is the probability of drawing a ball that is greater than 7 or is even? Sometimes it's good to do what's called a Venn diagram to help you see and appreciate the fact that these two events are not mutually exclusive. If this box here represents all the sample space, that means every possible outcome. Now, every possible outcome is a ball that's a 1, 2, 3, 4, all the way up to 10. So there are 10 different outcomes. So that's the sample space, and I'm going to put these numbers in. What is the probability of drawing a ball that is greater than 7? Now, greater than 7 does not include 7, so it is 8, 9, and 10. So that is greater than 7, 8, 9 and 10. Now all the rest can go around the outside, but the other one we're interested in is even. So we can put in here 2, 4, 6, then we've got 8 and 10. So there is another event. And you can see that because we've got overlap between the two different events, they're not mutually exclusive. If they were mutually exclusive events, then there would be two circles or loops or whatever that don't overlap each other. But because we get overlapping here with 8 and 10, it means they are not mutually exclusive. So that's not the total. Sample space are all possible outcomes. So we still haven't got 1, we still haven't got 3, 5 and 7. So we've got the total sample space now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all possible outcomes. So what is the probability of drawing a ball that is greater than 7? Greater than 7 is this event here, 8, 9, 10. And or is even, not and, or is even, or is this one here. So that makes our working out our probability a bit easier. Probability that is greater than, we'll just use the greater than 7, or even. Using the addition principle, we know they're not mutually exclusive, so it'll be the probability that they are greater than 7, plus probability it's even. Now, because they're not mutually exclusive, minus the probability greater than 7 and even. Okay, greater than 7 is this one here. How many of those? 1, 2, 3 out of 10. Probability even. We've got 1, 2, 3, 4, 5, so that's plus 5 on 10. Minus probability greater than 7 and even. Now, greater than 7 and even is the overlap between these two events. So, if you like, this is the overlap, which will be this one here, which is 2. There's 2 in there, the 8 and the 10, so minus 2 over 10. So 3 and 2 is 5, minus 2 is 3 and 5 is 8, minus 2 comes back to 6 over 10. And that's equal to, divide by 2 top and bottom, 3 over 5. Okay, so this may help, may not. It's for some people who find it hard to visualise these sorts of things. This may make it easier to do what's called a Venn diagram, V-E-N-N. And you can see each of the events, and you can see the fact that if they do have some in common, then they are not mutually exclusive. In this case, 8 and 10 are both greater than 7 and even. So that's why we've got the 2 there, and 3 plus 5, 8 minus 2 is 6, and we get 3/5.